Hello friends, welcome to i-TUTOR NCERT series. Today we are going to discuss Class 11 Geography NCERT Fundamentals of Physical Geography Chapter 6 Landforms and their Evolution. Let's start. Erosion causes changes on the surface of Earth. Deposition follows erosion, and because of deposition too, changes occur on the surface of the Earth. Now, what is called landforms? Look at this definition. Small to medium tracts or parcels of the Earth's surface, that is called landforms. Several related landforms together make up landscapes. Each landform has its own physical shape, size, materials, and is a result of the action of certain geomorphic processes and agents. Okay, so last class we discussed about some geomorphic processes. Now, action of most of the geomorphic process and the agents are slow, and hence the results take a long time to take shape. Every landform has beginning. Now, landforms once formed may change in their shape, size, and nature slowly or fast due to continental action of geomorphic process and agents. Okay, now wait for a minute. Okay. So landforms once formed may change in their shape, size, and nature slowly or fast due to continued action of geomorphic process and the agents. Due to changes in climatic conditions and vertical or horizontal movements of the land masses, either the intensity of processes or the processes themselves might change, leading to new modifications in the landforms. Evolution here implies stages of transformation of either a part of Earth's surface from one landform into another, or transformation of individual landforms after they are once formed. Okay, so what is evolution here implies? It implies that the stages of transformation of either a part of Earth's surface from one landform into another, or transformation of individual landforms after they were once formed. That means each and every landform has a history of development and changes through time. A landmass passes through stages of development somewhat comparable to the stages of life, that is youth, mature, and old age. Now, running water. In humid regions which receive heavy rainfall, running water is considered the most important of the geomorphic agents in bringing about the degradation of the land surface. There are two components of running water. One is overland flow on general land surface as a sheet, and another is linear flow as streams and rivers in valleys. Okay, so there is generally two components of running water. First one is the overland flow on general land surface as sheet, and second one is it's a linear flow and it's like streams and rivers in valley area. Most of the erosional landforms made by running water are associated with vigorous and youthful rivers flowing over steep gradients. With time, stream channels over steep gradients turn gentle due to continued erosion, and as a consequence lose their velocity, facilitating active deposition. There may be depositional forms associated with streams flowing over steep slopes. Okay, so what happened there? There may be depositional forms which are associated with the streams flowing over steep slopes. But these phenomena will be on a small scale compared to those associated with the rivers flowing over medium to gentle slopes. Okay, so this is very low. What the depositional forms associated with the streams flowing over steep slopes. Okay, so there is a small scale compared to the river flowing over medium to gentle slopes. Okay, so the deposition in this area, that is the streams flowing over steep slopes, that is less compared to the association with the rivers flowing over medium to gentle slopes. The gentler the river channels is in gradient or slope, the greater is the deposition. Okay, so the gentler the river channel in the gradient or in the slope, that is the greater in deposition. Okay, so there is the great deposition occur. When the stream beds turn gentler due to continued erosion, downward cutting become less dominant and lateral erosions of banks increases, and as a consequence the hills and valleys are reduced to plains. Okay, so as a consequences what happened? The hills and valleys are reduced to plains. Now, overland flow causes sheet erosion. Okay, so what causes sheet erosion? The overland flow which causes sheet erosion. Depending upon irregularities of the land surface, the overland flow may concentrate into narrow to wide paths. Because of the shear friction of the column of flowing water, minor or major quantities of materials from the surface of the land are removed in the direction of the flow, and gradually small and narrow rills which form. Okay, so if the shear friction of column of flowing water, the minor or major quantities of materials from the surface of the land are removed, and that removed in the direction of the flow, and they gradually small and narrow rills will form. These rills will gradually develop into long and wide gullies. Okay, so first one is rills. Okay, and they developed into gullies. Now, the gullies will further deepen, widen, lengthen and unite to give rise to a network of valleys. Okay, so rills, gullies, and then it developed to form valleys. Okay. Now, in the early stage, downcutting dominates, during which irregularities such as waterfalls and cascades will be removed. Okay, so what happened in early stage? The downcutting dominates. Okay, downcutting dominates, and during which irregularities such as waterfalls and cascades will be removed. But in the middle stage, okay, there is three stages. First one we already discussed about the three stages. What are they? First one is youth stage, then mature stage and old age. So in the young stage or the first stage, what happened? There will be downcutting dominates, okay, and the waterfalls and cascades will be removed. In the middle stage, the streams cut their beds lower and lateral erosion of valley sides become severe. Gradually, the valley sides are reduced to lower and lower slopes. The divides between drainage basins are likewise lowered until they are almost completely flattened, leaving finally a low land of faint relief with some low resistant remnants called monadogs standing out here and there. Okay. Now, this type of plain forming as a result of stream erosion is called peneplain, that is an almost plain. The characteristics of each of the stages of landscape developing in running water regimes may be summarized as follows. Okay, so there is three stages. First one is youth stage. Streams are few during this stage. Okay, so in this stage the streams are few. Now, with poor irrigation and flow over original slopes showing shallow V-shaped valleys with no floodplains or with very narrow floodplains along trunk streams. Okay, so the first stage is youth stage, and in this stage streams are few and the poor irrigation and flow over original slopes and which showing shallow V-shaped valleys with no floodplains or with very narrow floodplains. Okay, in this stage there is no floodplains, or we can see only a little floodplains, and it has trunk streams. Now, streams divides and broad and flat with marshes, swamp and lakes. Meanders, if present, develop over these broad upland surfaces. Okay, so here we can see the meanders also. Okay, these meanders may eventually entrench themselves into the uplands. Okay, so these meanders eventually entrench themselves into the uplands, and waterfalls and rapids may exist where local hard rock bodies exposed. Okay, so we can see the waterfalls and rapids in this area, but the condition is they exist local hard rock bodies. Okay, So that is about the youth stage. Now mature stage, that is the second stage. During this stage, streams are plenty with good integration. Okay, so in this stage what happened? The streams are plenty and they have good integration. The valleys are still V-shaped but deep. Okay, so in this stage what happened? Deep V-shaped valleys. Okay, deep V-shaped valleys. Trunk streams are broad enough to have wider floodplains within which streams may flow in meanders confined within the valley. The flat and broad interstream areas and swamps and marshes of youth disappear and the stream's divides turn sharp. Waterfalls and rapids disappear. Okay, so in this stage we can't find any waterfalls and rapids. Okay, so because it disappear in this stage. Now the final one is the old stage. Smaller tributaries during old age are few with gentle gradients. Streams meander freely over vast floodplains, showing natural levees, oxbow lakes, etc. Okay, so in this stage we can see the natural levees and oxbow lakes. Divides are broad and flat with lakes, swamps and marshes. Most of the landscape is at or slightly above sea level. Okay, so in this area, this phase, most of the landscape that is at or above the sea level. Now, erosional landforms. First one, valleys. Valleys start as small and narrow rills. The rills will gradually develop into long and wide gullies. The gullies will further deepen, widen and lengthen to give rise to valleys. Okay, so we already discussed what happened. First one rills, then it formed to gullies and gullies into valleys. Depending upon dimension and shape, many types of valleys like V-shaped valley, gorge, canyon, etc. can be recognized. Okay, so there are many types of valleys. Example, V-shaped, gorge, canyon. Now, what is a gorge? A gorge is a deep valley with very steep to straight sides. Okay, so a gorge is a deep valley and it have a very steep to straight sides. And a canyon is characterized by steep step-like and side slopes. Okay, so what is the difference between gorge and canyon? And gorge, it is deep valley and they have very steep to straight sides, but the canyon, it have steep steps like side slopes and may be as deep as a gorge. A gorge is almost equal in width at its tops as well as its bottom. Okay, so a gorge is almost equal in width at its top as well as its bottom. In contrast, a canyon is wider at its top. Okay, so canyon, its top is wider and its bottom is narrow. Okay, so its top is wider and the bottom is narrow. Now, in fact, a canyon is a variant of gorge. Valley types depends upon the type and structure of rocks in which they form. For example, canyons commonly form in horizontal bedded sedimentary rocks and gorges form in hard rocks. Okay, so the canyons, they are mainly form in canyons are commonly formed in horizontal bedded sedimentary rock. Okay, and gorges mainly in hard rocks. Okay, so that is valleys and that is about the valleys. Now, potholes and plunge pools. Over the rocky beds of hill streams, more or less circular depression, they are called potholes forms because of the stream erosion aided by the abrasion of rock fragments. Okay, so what is pothole? Over the rocky bed of hill streams, more or less circular depression. Okay, so the potholes are a circular depression. There are circular depression. They form because of stream erosion aided by the abrasion of rock fragments. Once a small and shallow depression forms, pebbles and boulders get collected in those depressions and get rotated by flowing water, and consequently the depression grow in dimensions. Okay, so what happened? First, it may be a small depression, and the pebbles and other things are collected here. And due to the effects of water, what happened? It started rotating inside this hole, and slightly the area becomes started to wide. Okay. Now, a series of such depressions eventually join and the stream valley gets deepened. At the foothills of waterfalls also, large potholes quite deep and wide form because of the sheer impact of water and rotation of boulders. Such large and deep holes at the base of waterfalls are called plunge pools. Okay, so we know what is potholes. Now, what is plunge pools? Sometimes assume this as a waterfall. Okay, this is water and it falls to this area. Then what happened? At the bottom of this waterfall, okay, due to the effect of water or due to the pressure of this water, what happened? This area, okay, this area may started to form holes, okay, and this may be deep, okay, the holes may be deep, and these are called plunge pools. Okay, so the plunge pools are commonly found in the areas of waterfalls. Okay, so that is the difference between potholes and plunge pools. Now, incised or entrenched meanders. In streams that flow rapidly over steep gradients, normally erosion is concentrated on the bottom of the stream channel. Also, in the case of steep gradient streams, lateral erosion on the sides of the valleys is not much when compared to the streams flowing on low and gentle slopes. Because of active lateral erosion, streams flowing over gentle slopes develop sinuous or meandering courses. It is common to find meandering courses over floodplains and delta plains where streams gradients are very gentle. Okay, so the meandering courses are mainly found in the floodplains and the delta plains area where the stream gradients are very gentle. But very deep and wide meanders can also be found cut in hard rocks. Such meanders are called incised or entrenched meanders. Okay, so very deep and wide meanders. They can also be found cut in hard rocks, and these are called incised or entrenched meanders. Now, river terraces. River terraces are surfaces marking old valley floor or floodplain levels. Okay, so what is river terraces? They are surfaces marking old valley floor or floodplain levels. They may be bedrock surfaces without any alluvial cover or alluvial terraces consisting the stream deposits. River terraces are basically products of erosion as they result due to vertical erosion by the stream into its own depositional floodplains. There can be a number of such terraces at different heights indicating former river bed levels. The river terraces may occur at the same elevation on either side of the rivers, in which case they are called paired terraces. Okay, so that is about the river terraces. Now, depositional landforms. First one is alluvial fans. Alluvial fans are formed when streams flowing from higher levels break into foot slope plain of low gradient. Okay, so how alluvial fans are formed? It's formed when streams flowing from higher levels and which break into foot slope plains of low gradient. Normally, very coarse load is carried by streams flowing over mountain slopes. This load becomes too heavy for the streams to be carried over gentler gradients and gets dumped and spread as a broad low to high cone shaped deposits called alluvial plain. Okay, so it's a broad low to high cone shaped deposits. Usually, the streams which flow over fans are not confined to their original channels for long and shift their position across the fan, forming many channels called distributaries. Okay, so such many channels, these are called distributaries. Alluvial fans in humid areas show normally low cones with gentle slope from head to toe, and they appear as high cones with steep slope in arid and semi-arid climates. Okay, so that's about the alluvial fans. Next one, deltas. Deltas are like alluvial fans but develop at a different location. Okay, so they are mainly developed on the load carried by a river is dumped and spread into the sea. If this load is not carried away far into the sea or distributed along the coast, it spread and accumulates as a low cone. Okay, so normally the load carried by rivers is dumped and spread into the sea. But if this load is not carried away far into the sea or distributed along the coast, it spread and accumulates as a low cone. Unlike in alluvial fans, the deposits making up deltas are very well sorted with clear stratification. The coarsest materials settle out first are the final fractions like silts and clays are carried out into the sea. As the delta grows, the river distributaries continue to increase in length and the delta continues to build up into the sea. Now, floodplains, natural levees and point bars. Deposition develops a floodplain just as erosion makes valleys. Okay, so the deposition develops a floodplains like the erosion makes valleys. Okay, floodplain is the major landform of a river deposition. Okay, so floodplain is a major landform of the river deposition. Large sized materials are deposited first when stream channels breaks into a gentle slope. Thus, normally fine sized materials like sand, silt and clay are carried by relatively slow moving waters in gentler channels usually found in the plains and deposited over the bed, and when the water spills over the banks during flooding above the bed. A riverbed made of river deposits is the active floodplains. Okay, so a riverbed made of river deposits is the active floodplain. The floodplain above the bank is inactive floodplain. Okay, so the floodplain above the bank, that is called inactive floodplain. Inactive floodplain above the banks basically contain two types of deposits. First one, flood deposits, and second one, channel deposits. In plains, channels shift laterally and change their course occasionally, leaving cut-off courses which get filled up gradually. Such areas over floodplains built up by abandoned or cut-off channels contain coarse deposits. The flood deposits of spilled waters carry relatively finer materials like silt and clay. The floodplains in a delta are called delta plains. Okay, so the floodplains in a delta, that is called delta plains. Now, what is natural levees? Natural levees and point bars. They are some of the important landforms found associated with floodplains. Natural levees are found along the banks of large rivers. They are low, linear and parallel ridges of coarse deposits along the bank of rivers, quite often cut into individual mounds. Point bars are also known as meander bars. Okay, so the point bars are also known as meander bars. They are found on the concave side of the meander of large rivers and are sediments deposited in a linear fashion by flowing waters along the bank. They are almost uniform in profile and in width and contain mixed size of sediments. Okay, so they are almost uniform in profile and in width and contain mixed size of sediments. They contain mixed size of sediments. Now, next one is meanders. In large flood and delta plains, Rivers rarely flow in straight courses. Loop-like channel patterns called meanders develop over flood and delta plains. Meander is not a landform. Okay, so meander is not a landform, but is only a type of channel pattern. This is because of first one, propensity of water flowing over very gentle gradients to work laterally on the banks. Now, second one, unconsolidated nature of alluvial deposits making up the banks with many irregularities which can be used by water exerting pressure laterally. And third one, Coriolis force acting on the fluid water deflecting it like it deflects the wind. Okay. When the gradient of the channel becomes extremely low, water flow leisurely and starts walking laterally. Slight irregularities along the banks slowly get transformed into a small curvature in the banks. The curvature depends due to deposition on the inside of the curve and erosion along the banks on outside. If there is no deposition and no erosion or undercutting, the tendency to meander is reduced. Normally, in meanders of large rivers, there is active deposition along the concave bank and undercutting along the convex bank. The concave bank is known as cutoff bank, which shows up as a steep scrap, and the convex bank present a long gentle profile. Okay, as meander grow into deep loops, the same may get cut off due to erosion at the inflection points and are left as oxbow lakes. Look at this picture. We can see this is the point bars. Okay, so these are point bars. Now, this is also point bars. Now, look at this. This is meander. Okay, so this is called meander. Okay, and this is oxbow lake. Okay, that is it cut off from the main river and form another one. It is called oxbow lake. Okay, this is lip of bank, then right bank and left bank. Okay, that's all. Now moving forward, groundwater. Here the interest is not on groundwater as a resource. Our focus is on the work of groundwater in the erosion of land masses and evolution of landform. Okay, so we know groundwater is a resource, but that is not important because we have to check how the groundwater work as a erosional landmass. Okay, erosion material. Okay, how it helps the evolution of landforms. Okay, let's check. The surface water percolates well when the rocks are permeable, thinly bedded and highly joined and cracked. After vertically going down to some depth, the water under the ground flows horizontally through the bedding planes, joints or through the materials themselves. It is this downward and horizontal movement of water which causes the rocks to erode. Physical or mechanical removal of materials by moving groundwater is insignificant in developing landforms. That is why the results of the work of groundwater cannot be seen in all types of rocks. But in rocks like limestone or dolomites rich in calcium carbonate, the surface water as well as groundwater through the chemical process of solution and precipitation deposition develop varies of landform. These two processes of solution and precipitation are active in limestones or dolomites, occurring either exclusively or interbedded with other rocks. Any limestone or dolomitic regions showing typical landform produced by the action of groundwater through the process of solution and deposition is called karst topography. Okay, so what is karst topography? Any limestone or dolomitic region which showing typical landforms produced by the action of groundwater through the process of solution and deposition. This process or this is called karst topography. After the typical topography developed in limestone rocks of karst region in the Balkans adjacent to Adriatic Sea. Now, the karst topography is also characterized by erosional and depositional landforms. First one, erosional landforms. Pools, sinkholes, lapis and limestone pavements. Small to medium-sized round to sub-rounded shallow depressions called shallow holes form the surface of limestones through solution. Sinkholes are very common in limestone or karst areas. A sinkhole is an opening more or less circular at the top and funnel shaped towards the bottom with sizes varying in area from a few square meter to a hectare and with a depth from a less than half a meter to 30 meters or more. Some of these form solely through solution action and other might start as solution forms first, and if the bottom of the sinkhole forms the roof of a void or cave underground, it might collapse leaving a large hole opening into cave or a void below, that is collapse sinks. Quite often sinkholes are give me a minute. Okay. Sinkholes are covered with soil mantle and appear as shallow water pools. Anybody stepping over such pools would go down like it happens in quicksands in deserts. The term doline is sometimes used to refer the collapse sinks. Solution sinks are more common than collapse sinks. Okay, so solution sinks are more common than the collapse sinks. Quite often, the surface runoff simply goes down shallow and sinkholes and flow as underground streams and reemerge at the distance downstream through a cave opening. When sinkholes and dolines join together because of slumming of materials along their margin or due to roof collapse of cave, long, narrow to wide trenches called valley sinks or uvalas form. Okay, so they are called valley sinks or uvalas. Gradually, most of the surface of limestone is eaten away by these pits and trenches, leaving it extremely irregular with a maze of points, grooves and ridges or lapis. Now, especially these ridges or lapis form due to differential solution activity along parallel to sub-parallel joints. The lapi field may eventually turn into somewhat smooth limestone pavements. Now, caves. In areas where there are alternating beds of rocks, that is shales, sandstone or quartzites. Okay, so the rocks may be shales, sandstones or quartzites. With the limestone or dolomites in between or in areas where limestone are dense, massive and occurring as thick beds, cave formation is prominent. Water percolates down either through the materials or through cracks and joints and moves horizontally along bedding planes. It is along these bedding planes that the limestone dissolves and long and narrow to wide gaps called caves result. There can be a maze of caves at different elevations depending upon the limestone beds and intervening rocks. Caves normally have an opening through which cave streams are discharged. Caves having opening at both the ends and are called tunnels. Okay, so if the caves have two sides opening, then it is called tunnels. Now, depositional landforms. Many depositional forms develop within the limestone caves. Okay, so there is many depositional forms that develop within the limestone caves. The chief chemical in limestone is calcium carbonate, which is easily soluble in carbonated water, that is carbon dioxide absorbed rainwater. This calcium carbonate is deposited when the water carrying it in solution evaporates or loses its carbon dioxide as it trickles over rough rock surfaces. Stalactites, stalagmites, and pillar stalactites hang as isolates of different diameters. Normally, they are broad at the base and taper towards the free ends, showing up in variety of forms. Okay, so they are broad at their base. Okay, at their base they are broad. Stalagmites rise up from the floor of the caves. Okay, so stalagmite rise up from the floor. This is the floor. Okay, this is the floor of a cave, and this is the top of a cave. Okay, top, this is the floor. Now, the stalagmite rise up from the floor. Okay, so it rise up from the floor of the caves. In fact, stalagmites form due to dripping water from the surface or through a thin pipe of stalactite immediately below it. Stalagmites may take from a shape of a column, a disc with either a smooth, rounded bulging end or a miniature crater-like depression. The stalagmite and stalactites eventually fuse to give rise to columns and pillars at different diameter. Okay, so the stalagmite rise up from the floor, and the stalagmite, it's maybe like this. Okay, and eventually the both of this form a pillar like structure. Okay, now the stalagmite and stalactites eventually fuse to give rise to columns and pillars of different diameters. Now, glaciers. Masses of ice moving as sheets over the land, that is continental glacier or Piedmont glacier. If a vast sheet of ice is spread over the plains at the foot of mountains, or as linear flows down the slopes of mountain in broad trough like valleys, are called glaciers. Okay, so what is simply it is called masses of ice moving as sheet over the land or as a linear flow down the slopes of mountains in broad trough like valleys are called glaciers. The movement of glaciers is low, unlike water flow. The movement could be a few centimeters to a few meters a day or even less or more. Glaciers move basically because of the force of gravity. Okay, so the glaciers mainly move because of the force of gravity. Erosion by glaciers is tremendous because of friction caused by sheer weight of ice. The material plucked from the land by glaciers get dragged along the floors or sides of the valleys and cause great damage through the absorption and plucking. Glaciers can cause significant damage to even unweathered rocks and can reduce high mountains into low hills and plains. Okay, so they can reduce high mountains into low hills and plains. As glaciers continue to move, debris gets removed, divides get lowered, and eventually the slope is reduced to such an extent that glacier will stop moving, leaving only a mass of low hills and vast outwash plain along with the other depositional features. Okay, so that's about the glaciers. Now, erosional landforms. First one is cirque. Cirques are the most common of landforms in glaciated mountains. The cirques quite often are found at the heads of glacial valleys. The accumulated ice cuts these cirques while moving down the mountain tops. They are deep, long, and wide throats or basins with very steep concave to vertically dropping high walls at its head as well as sides. A lake of water can be seen quite often within the cirques after the glacier disappears. Such lakes are called cirque or tarn lakes. There can be two or more cirques, one leading into another down below the stepped sequence. Now, horns and serrated ridges. Horns form through headward erosion of cirque walls. If three or more radiating glaciers cut headward until their cirque meets, high, sharp-pointed and steep-sided peaks called horns form. The divides between cirque side walls or head walls get narrow because of progressive erosion and turn into serrated or saw-toothed ridges, sometimes referred to as arêtes, with a very sharp crest and zigzag outline. Now, glacial valleys or troughs. Glaciated valleys are trough-like and U-shaped with broad floors and relatively smooth and steep sides. Okay, they have U-shaped and broad floors and they are relatively smooth and steep sides. The valleys may contain littered debris or debris shaped as moraines with swampy appearance. There may be lakes gouged out of a rocky floor or formed by debris within the valleys. There can be hanging valleys at an elevation on one or both sides of the main glacial valley. The faces of divides or spurs of such hanging valleys opening into main glacial valleys are quite often truncated to give them an appearance like a triangular facet. Very deep glacial troughs filled with seawater and making up shorelines are called fjords or fjords. Okay. Now depositional landforms. Okay. The unassorted coarse and fine debris dropped by the melting glacier is called glacial till. Most of the rock fragments in till are angular to subangular in form. Streams formed by melting ice at the bottom, sides, or lower ends of glaciers. Some amount of rock debris, small amount to be carried by such melt water streams is washed down and deposited. Such glaciofluvial deposits are called outwash deposits. Unlike till deposits, the outwash deposits are roughly stratified and assorted. The rock fragments in outwash deposits are somewhat rounded at their edges. Okay, so they are somewhat rounded at their edges. Now moraines. They are long ridges of deposits of glacial till. Terminal moraines are long ridges of debris deposits at the end, that is top, of the glaciers. Lateral moraines form along the sides parallel to glacial valleys. The lateral moraines may join in a terminal moraine forming a horseshoe-shaped ridge. There can be many lateral moraines on either side of the glacial valleys. These moraines partially or fully owe their origin to glaciofluvial waters pushing up materials to the sides of glacier. Many valleys glaciers retreating rapidly leave an irregular sheet of till over their valley floors. Such deposits, varying greatly in thickness and in surface topography, are called ground moraines. The moraine in the center of the glacier valley flanked by lateral moraine is called medial moraine. They are imperfectly formed as compared to lateral moraines. Sometimes medial moraines are indistinguishable from the ground moraines. Okay, so that's about the moraines. Now, eskers. When glaciers melt in summer, the water flows on the surface of the ice or seeps down along the margins or even moves through the holes in the ice. This water accumulates beneath the glacier and flow like streams in a channel beneath the ice. Such streams flow over the ground, that is not in a valley cut in the ground, with the ice forming its banks. Now, very coarse materials like boulders and blocks along with some minor fractions of rock debris carried into this stream settle in the valley of ice beneath the glacier, and after the ice melts can be found as synogous ridge called esker. Outwash plains. The plains in the foot of the glacial mountains or beyond the limits of continental ice sheets are covered with glaciofluvial deposits in the form of broad, flat alluvial fans which may join to form outwash plains or gravel, silt, sand and clay. Okay, so that's about the outwash plain. Okay, now drumlines. The drumlines are smooth oval shaped ridge-like features composed mainly of glacial till with some masses of gravel and sand. Okay, so what are drumlines? They are smooth oval shaped ridge-like features and they are composed mainly of glacial till with some masses of gravel and sand. The long axes of drumline are parallel to the direction of ice movement. Okay, so the long axes of drumline, they are parallel to the direction of movement. Okay, they may measure up to 1 kilometer in length and 30 meters or so in height. One end of the drumline facing the glacier called the Stoss end, okay, is blunter and steeper than the other end called tail. Okay, so the one end of the drumline that is facing the glacier that is called Stoss end, and it is blunter and steeper than the other end, and the other end is called tail. The drumlines form due to drumming of rock debris beneath heavily loaded ice through fissures in the glacier. The Stoss end gets blunted due to pushing by moving ice. Drumlines give an indication of direction of glacier movement. Okay, so the drumline gives an indication of the direction of glacier movement. Now, waves and currents. Coastal processes are the most dynamic and hence most destructive. Okay, so the coastal processes are most dynamic and it's also destructive. Some of the changes along the coast take place very fast. At one place, there can be erosion in one season and a deposition in another. Most of the changes along the coast are accomplished by waves. When waves break, the water is thrown with great force onto shore, and simultaneously, there is a great churning of sediments on the sea bottom. Constant impact of breaking waves drastically affect the coast. Storm waves and tsunami waves can cause far-reaching changes in the short period of time than normal breaking waves. As wave environment changes, the intensity of the force of breaking waves changes. Now, other than action of waves, the coastal landforms depend upon the configuration of the land and the seafloor, whether the coast is advancing seaward or retreating landward. Assuming sea level to the constant, two types of coast are considered to explain the concept of evolution of the coastal landforms. First one, high rocky coast. Second one, low, smooth and gently sloping sedimentary coast. Now, high rocky coast. Along the high rocky coast, the rivers appear to have been drawn with highly irregular coastline. Okay, so the rivers are highly irregular coastline. The coastline appears highly indented with extension of water into the land where glacial valleys are present. The hillsides drop off sharply into the water. Shores do not show any depositional landforms initially. Erosion features dominate. Okay, so here the erosion feature dominates. Along high rocky coast, waves break with great force against the land, shaping the hillsides into cliffs. With constant pounding by waves, the cliffs recede, leaving a wave-cut platform in front of the sea cliff. Waves gradually minimize the irregularities along the shore. The material which fall off and are removed from the sea cliffs gradually break into smaller fragments and roll to roundness will get deposited in the offshore. After a considerable period of cliff development and a retreat, when coastline turns somewhat smooth with the addition of some more material to its deposit in the offshore, a wave-built terrace would develop in front of wave-cut terrace. As the erosion along the coast takes place, a good supply material becomes available to the long shore currents and waves to deposit them as beaches along the shores and as bars in the near shore zone. Bars are submerged features, and when bars show up above water, they are called barrier bars. Okay, the bars are submerged features, but when the bars show up above the water, then it is called barrier bars. Barrier bars which get keyed up to the headline of bay is called spit. Okay, so the barrier bar which get keyed up to the headline of the bay, that is called spit. When barrier bars and spit form the mouth of a bay and block it, a lagoon forms. The lagoons would gradually get filled up by sediments from the land, giving rise to a coastal plain. Now, low sedimentary coast. Along low sedimentary coast, the rivers appear to extend their length by building coastal plains and deltas. Okay, they're building coastal plains and deltas. The coastline appears smooth with occasional incursion of water in the form of lagoons and tidal creeks. The land slopes gently into the water. Okay, so the land slopes gently into the water. Marshes and swamps may abound along the coast. Depositional features dominate. Okay, so here depositional features are dominate. Okay, in low sedimentary coast, depositional features dominate, but at the same time in the high rocky coast, there is erosional features dominate. Okay, now when waves break over a gently sloping sedimentary coast, the bottom sediments get churned and move readily, building bars, barrier bars, spilt, and lagoons. Okay, so they create bars, barrier bars, spits, and lagoons. Lagoons would eventually turn into a swamp, which would subsequently turn into a coastal plain. Okay, so the lagoon may change into a swamp, and the swamp may subsequently turn into a coastal plain. The maintenance of these depositional features depend upon the steady supply of materials. Storms and tsunami waves cause drastic change irrespective of supply of sediments. Large rivers which bring loads of sediments build delta along low sedimentary coast. Okay, sorry. Now, erosional landforms, that is cliffs, terraces, caves, and stacks. Wave-cut cliffs and terraces are two forms usually found where erosion is the dominant shore process. Okay, almost all sea cliffs are steep and may range from a few meter to 30 meter or even more. At the foot of such cliffs, there may be a flat or gently sloping platform covered by a rock debris derived from the sea cliff behind. Such platforms occur at elevations above the average height of waves is called wave-cut terraces. Okay, so platforms occur at the elevation above the average height of waves. Okay, they are above the average height of waves, and that is called wave-cut terrace. Now, the lashing of waves against the base of the cliff and the rock debris that gets smashed against the cliff along with the lashing from the sea, smashed against the cliff along with the lashing waves create hollow, and this hollow gets widened and deepened to form sea caves. Okay, so the lashing of waves against the base of the cliff and the rock debris that gets smashed against the cliff along with lashing waves, and that create a hollow structure, and this hollow get widened and deepened, and this is formed sea caves. Okay, so this hollow and this widened and deepened hollow, that is called sea caves. The roofs of caves collapse and the sea cliffs are recede further inland. Retreat of the cliff may leave some remnants of rock standing isolated as small islands just off the shore. Such resistant masses of rocks originally part of a cliff or hill are called sea stacks. Like all other features, sea stacks are also temporary, and eventually coastal hills and cliffs will disappear because of wave erosion giving rise to narrow coastal plains. And with the onrush of deposits from over the land, behind may get covered up by alluvium or may get covered up by shingle or sand to form a wide beach. Okay. Depositional landforms. Beaches and dunes. Beaches are characteristics of shoreline that are dominated by deposition, but may occur as patches along even and rugged shores. Most of the sediments making up the beaches comes from land carriers by the streams and rivers or from wave erosion. Beaches are temporary features. The sandy beach, which appears so permanent, may be reduced to a very narrow strip of coarse pebbles in some other season. Most of the beaches are made up of sand-sized materials. Beaches called shingle beaches contain excessively small pebbles and even cobbles. Okay, so the shingle beaches contain excessively small pebbles and even cobbles. Just behind the beach, the sands lifted with winnowed from over the beach surface will be deposited as sand dunes. Sand dunes forming long ridges parallel to the coastline are very common along low sedimentary coast. Okay, so the sand dunes forming long ridges parallel to the coastline, they are very common along the low sedimentary coast. Now bars, barriers and spit. A ridge of sand and shingle formed in the sea in the offshore zone lying approximately parallel to the coast is called an offshore bar. An offshore bar which is exposed due to further addition of sand is termed as barrier bar. The offshore bars and barrier commonly form across the mouth of a river or at the entrance of a bay. Sometimes such barrier bars get keyed upon to the up to one end and the one end of the bay and they are called spits. Okay, so sometimes these barrier bars they get keyed up to one end of the bay when they are called spits. Spits may also develop attached to headlands or hills. The barriers or bars and spits at the mouth of the bay gradually extended, leaving only a small opening of the bay into the sea, and the bay will eventually develop into lagoon. Okay, so the bay will eventually develop into lagoons. The lagoons get filled up gradually by sediments coming from the land or from the beach itself, and a broad and wide coastal plain may develop replacing a lagoon. Okay, so that is bars, barriers and spits. Now winds. Wind is one of the two dominant agents in hot deserts. The desert floors get heated up too much and too quickly because of being dry and barren. The heated floors heat up and the air directly above them and result in upward movements in the hot lighter air with the turbulence and any obstructions in its path set up eddies, whirlwind, updraft and downdraft. Winds also move along the desert floors with a great speed and the obstruction in their path create turbulence. Of course, there are storm winds which are very destructive. Wind causes deflation, abrasion and impact. Deflation includes lifting and removal of the dust and smaller particles from the surface of the rocks. In the transportation process, sand and silt act as effective tool to abrade the land surface. The impact is simply sheer force of momentum which occurs when sand is blown into or against a rock surface. It is similar to sand blasting operation. The wind action creates a number of interesting erosional and depositional features in the desert. In fact, many features of deserts owe their formation to mass wasting and running water as sheet floods. Though rain is scarce in deserts, it comes down torrentially in a short period of time. The desert rocks devoid of vegetation exposed to mechanical and chemical weathering process due to drastic diurnal temperature changes decay faster and the torrential rains helps in removing the weathered material easily. That means the weathered debris in desert is moved by not only wind but also by a rain sheet wash. The wind moves fine materials and general mass erosion is accomplished mainly through sheet floods or sheet wash. Stream channels in desert areas are broad, smooth and indefinite and flow for a brief time after rains. Now erosional landforms. Pediments and pediplains. Landscape evolution in desert is primarily concerned with the formation and extension of pediments. Jelly, inclined rocky floors close to the mountains at their foot or with or without a thin cover of debris are called pediments. Okay, so they are generally inclined rocky floors close to mountains at the foot with or without a thin cover of debris, that is called pediments. Such rocky floors form through the erosion of mountain front through a combination of lateral erosion by streams and sheet flooding. Erosion starts along the steep margins of the landmass or the steep sides of the tectonically controlled steep incision features over the landmass. Once pediments are formed with a steep wash steep wash slope followed by cliff or free face above it. The steep wash slope and a free face retreat backwards. This method of erosion is termed as parallel retreat of slopes through backwasting. Okay, so this method of erosion, this is termed as parallel retreat of slopes through backwasting. So, through parallel retreat of slopes, the pediments extend backward at the expense of mountain front, and gradually the mountains get reduced, leaving an inselberg which is a remnant of the mountain. That's how the high relief in desert area is reduced to low featureless plains called peדיplains. Okay, so the low featureless plain, these are called peδιplains. Now playas. Plains are by far the most predominant landforms in the deserts. In basins with mountains and hills around and along, the drainage is towards the center of the basin, and due to gradual deposition of sediments from the basin margins, a nearly level plain forms at the center of the basin. In times of sufficient water, this plain is covered up by shallow water body. Such types of shallow lakes are called playas, where water is retained only for short duration due to evaporation, and quite often the playas contain good deposition of salt. The playa plain covered by salt is called alkali flats. Now, deflation hollows and caves. Weathered mantle from over the rocks or bare soil gets blown out by persistent movement of wind currents in one direction. This process may create shallow depression called deflation hollows. Okay, so it's a shallow depression. Deflation also creates numerous small pits or cavities over rock surfaces. The rock faces suffer impact and abrasion of wind-borne sand, and first shallow depressions called blowouts are created, and some of the blowouts become deeper and wider fit to be called caves. Mushroom, table and pedestal rocks. Many rock outcrops in the deserts easily susceptible to wind deflation and abrasion are worn out quickly, leaving some remnants of resistant rocks polished beauty in the shape of mushroom with a slender stalk and a broad and rounded pear-shaped cap above. Sometimes the top surface is broad like a tabletop, and quite often and the remnant stands out like pedestals. Okay, so that is table and a pedestal rock, and if the size is like a mushroom, then it's called a mushroom rocks. Depositional landforms. Wind is a good sorting agent. Depending upon the velocity of wind, different sizes of grains are moved along the floor by rolling or saltation and carried in suspension, and in this process of transportation itself, the materials get sorted. Okay, so in this process of transportation itself, the material gets sorted. When the wind slows or begin to lie down, depending upon sizes of grains and their critical velocities, the grains will begin to settle. So in the depositional landforms made by wind, good sorting of grains can be found. Since wind is there everywhere, and wherever there is a good source of sand and with a constant wind direction, deposition of features in arid regions can develop anywhere. Now sand dunes. Dry hot deserts are good places for sand dune. Okay, so the dry hot deserts are good places for the sand dunes. Sand dune formation. Obstacles to initiate dune formation are equally important. There can be a great variety of dune forms. Crescent-shaped dunes called birchens with the points or wings directed away from the wind direction, that is downwind, form where the wind direction is constant and moderate, and where the original surface over which sand is moving is almost uniform. Parabolic dunes form when sandy surfaces are partially covered with vegetation. That means parabolic dunes are reversed birchens with the wind direction being the same. Safe is similar to birchen with a small differences. Safe has only one wing or point. This happens when there is shift in the wind condition. The long wings of safes can grow very long and high. Longitudinal dunes form when supply of sand is poor and wind direction is constant. They appear as long ridges of considerable length but low in height. Transverse dunes are aligned perpendicular to wind direction. These dunes form when the wind direction is constant and the source of sand is an elongated feature at right angle to the wind direction. They may be very long and low in height. When sand is plenty, quite often the regular shaped dunes coils and lose their individual characteristics. Most of the dunes in the desert shift and a few of them will get stabilized, especially near human habitations. Okay, so look at this picture, you can see different types of dunes. Okay, like Bertrand's cells, transverse, parabolic. Okay, so that's about the chapter. If you have any doubts, you can comment below. For more related contents, do like, share, subscribe.